All right, guys. So what I want to mention at the start is just a few things about your test three. So those test three grades, I think you can see them on WebAssign. I was able to see those, and if anyone didn't complete, but I have not had a chance to kind of go through and look at the tests and just kind of scan for errors. I will do that. I will open up each one and just kind of look and see if there's anything that's a small typo error where WebAssign didn't count it, but you really deserve credit. But I encourage each of you to do that to your own test because if there's something where you typed a comma instead of a decimal place, I'm going to give you override credit. So make sure you look at that carefully. If there's something that you put that you feel deserves partial credit that WebAssign didn't score, let me know. I can go in there and look at those individually and just kind of troubleshoot those. So as soon as those get updated, probably later today or tomorrow, I'll get those grades on Blackboard and update your current average. Any questions about either administrative things or kind of Unit 3 wrap up before we go on? You can type it into your chat box or I'm mute either way. All right, so I don't see any. Hopefully you guys had a good break in spite of having to finish up work stuff. This today starts our intro to Unit 4, and we're actually going to have a little bit of a shorter Unit 4, just the way things have fallen and the week that we had canceled. We're going to spend 2 weeks in Unit 4, this week and next week. Then the following week, the last week of class, we will spend doing Test 4, reviewing in Test 4, and then the optional final for those people who want to take that. All of those things will be online with more details to come. The Unit 4 test will be on WebAssign, very similar to how the Unit 3 test was. So we'll kind of think through the format and the types of things that we could see. It'll be a little bit different than a paper and pencil test, particularly for the trig identities in 5.1 and 5.2. And then when we get ready for the optional final, that is also going to be on WebAssign. So let's go ahead and jump into Unit 4 with a recap of some trig identities. Now, when we had gotten started with what was supposed to be Unit 3, I had started the trig identities because we've had some reordering of our sections, and I was going to jump in there. Then when we had our cancellation with coronavirus, it kind of changed the plan a little bit to allow us to do some of the easier material first with hopes that maybe we would be able to come back together and tackle trig identities, which isn't the case. But the good thing is we have already had a full day exploring trig identities. However, that was several weeks ago. So the objective today is to do a refresh of what was going on in 5.1, do a bunch of trig identities practice, and kind of get into 5.2, which is more of trig identities. You will notice on your WebAssign, 5.1 is the original 5.1 that was already posted, no changes. So if you had already started that, you'll see that your work is already saved. However, 5.2, based on the length of 5.1, I edited that one down significantly, so it's a much shorter section. What I tried to do was pick between the two a good representation of trig identities. So let's go ahead and take a look at an overview of the identities we need to have in the back of our mind. I grabbed this just from your textbook, this box, and it's also in your course content. I'll make sure I link it when I send out this video later today so that you guys can print this off and have it handy. Your trig identities that you want to have in front of you kind of fall into several categories. The first is going to be your reciprocal identities. I think at this point, most of us have those trig identities, the reciprocal ones, memorized. So in particular, we think about cosecant, secant, and cotangent as the reciprocal identities. But you can also think about sine, cosine, and tangents as reciprocals of their reciprocal identities. So even though it's not customary to write sine as 1 over cosecant, sometimes when we're simplifying identities, sometimes it helps us out. So it's kind of nice to have that in front of us. Then our two quotient identities, tangent and cotangent, are good to know. Keep in mind, we have a reciprocal one that connects tangent and cotangent. So we're going to see a lot of kind of overlap as we go through these. Then we've talked about our Pythagorean identities several times, and we've used these when we're given one trig function to find the other 6, along with our quadrant information. We'll see that again reviewed in 5.1. But the main one I want you guys to remember is, that didn't look like a star, sine squared plus cosine squared equals 1, this first one. Then by dividing by either sine squared or cosine squared, we can get our 2 alternative Pythagorean identities. So what we want to be on the lookout for these ones as we go through is anything involving squares. If we kind of briefly scan the rest of the page, none of our other trig identities, or most frequently used trig identities, have squares. So when you see those squares, it means, hey, look back at Pythagorean, see if you can manipulate those into something that's helpful. Then our cofunction identities, think about these cofunction identities as taking you to a new name for the same function. So when we think about sine and cosine, we've said, hey, the graphs are similar. They're out of phase, or one is a phase shift of the other. But if we have a sine curve, we could do a shift and think about it as a cosine curve. So what that allows us to do is if we see a sine in an identity, we can do some manipulation often and represent it with a cosine. And this is the most common way to represent these cofunction identities, by using a pi/2 shift. So notice for our sine and cosine, I say those are the most frequently used, but the sine of pi/2 minus u, or minus x, gives us the cosine of u, or the cosine of x. So notice for each of these, the argument of our function is pi/2 minus u, or pi/2 minus x, if we're writing it like that. And what we want to notice is the pairings are what we would expect. Sine is paired with cosine. They're pi/2 shifts of one another. So notice we have these two telling you how to take a cosine. For example, if you had cosine of x, how to take it to a sine. Okay, the sine one will have the phase shift. Or if you have a sine, how to take it to the cosine. Then we have tangent and cotangent paired up, secant and cosecant paired up. So for these ones, understanding those phase shifts allows us to do replacements. If we are wanting to convert everything to sine, everything to cosine, this is the way to go. Then in terms of our last type, let's see, we have even and odd identities. So these are helpful. I found that I don't use them quite as frequently when I'm doing as much, but they're helpful because sometimes you might have something where you want to change where the negative appears. So if we think about the sine function for a second, let's ignore the identity that we have that I circled. Just think about the graph of your sine function. The graph of our sine function goes through the origin, keeps on going. And if we think about maybe just focusing on that center part around the origin, the sine function has odd symmetry, meaning we can rotate 180 degrees and it gives us an identical graph. Or for odd, we may remember this tells us if we input a negative x, we get out a negative y. So f of negative x equals negative f of x. Or expressed in trig form, sine of negative u equals negative sine of u. Then cosine is even, meaning if we look at cosine of negative u, we get cosine of u. And so the other ones, sine and cosine are going to be our most frequent. The other ones are going to be cosecant. So notice cosecant is odd. Secant is even. And then if we look at tangent and cotangent, notice we're putting in a negative u and getting out the negative tangent and negative cotangent. These guys are odd. Now, is it possible we could have things that are not either or odd, even or odd? Yes. In this case, we don't, though. We can look at each of our trig functions and classify them as one or the other. So keep these in your back pocket. And what we really want to be able to do is identify when we have an identity and transform an expression using our identities. So let me write down those main ideas. I'm going to call the first one, is it an identity? We're going to use Desmos to help us. And then transforming expressions. I like transforming better than simplifying. Sometimes our book will say simplify the expression using trig identities. And when we think about transforming or simplifying, oftentimes our goal is to condense. Make an expression that looks kind of complicated, much simpler. So I'm going to walk us through a variety of both types and discuss more of two, but then incorporating our number one. So before we go on, any questions so far on what we had in our identity page? Again, you can type something in the chat box or unmute yourself. Okay, so what I'm going to do is go ahead and go to our homework. And I'm going to start in the WebAssign homework 5.1. And part of the reason I'm going to start in our homework rather than the Desmos activity 5.1, which we're going to talk about, the exploring trig identities with Desmos, is because the types of questions you're going to see for practice and on the test are going to be formatted more like we're going to see in the WebAssign, and we're going to incorporate those things we're learning in the Desmos to check mainly. So let's take a look at, if you have yours with you, go ahead and pull up that 5.1. And what you're going to notice about 5.1 is that they start off just reviewing your basic identities, and then they start asking you to simplify. So for example, your number one may look a little different, but mine looks like cosine u over sine u equals. And all you have to do is fill in the blank and complete the trig identity. So this one is looking at your forms and knowing those reciprocals and knowing that this is cotangent. My little one is asking me a question here. Mama, sorry, guys. Hey, Harrison, I want you to go ahead and have a seat, buddy, until I can help you, okay? Not right now. Sorry, guys. So for this one, once you get here, that's it. Now, if we wanted to use Desmos to check, which we're not going to flip over on this one, but we can think about side one versus side two. If you graph equation or the left side as an equation, y equals this, y equals cosine u over sine u, cosine x over sine x, and y2 equals cotangent u, just in lines and Desmos, these should match up. If they match up, you know you've done it right and it checks. So in particular on your homework, 2, 3, 4, all of those, even through, I would say number 6, numbers 1 through 6, are very similar to this type. Look at your identities and be able to identify. Then when we get to number 7, this is actually similar to something we've seen on multiple tests before. It tells you, given the certain conditions and one trig value, find the other 5. So in this case, what they actually tell you is that the secant equals -5/2, and the tangent of x is less than 0. Now, on this particular one, notice that the tangent less than 0 narrows you down to 2 quadrants. And then knowing the sign of your secant, the plus or minus, allows you to narrow down further. So what it's asking you for in this one is to find the value of all 6 trig functions. We already know the secant. So sine, cosine, tangent, cosecant, secant, and cotangent. Now, let's take a look at how to do this one, just as a quick review. We're not going to work through the whole thing, but most of you are pretty good on test 2 at doing this and a little bit on test 1. So think about your tangent. Quadrant 1, 2, 3, and 4. And in quadrant 1, cosine and sine are both positive, so our tangent is positive. And then in quadrant 2, we know that cosine is negative, sine is positive, tangent's negative. In quadrant 3, cosine and sine are both negative, so our tangent is positive. And in quadrant 4, our tangent is negative. So this allows us to narrow down to 2 and 4. And then if we think about the secant, first place I would go with this is convert to sine and cosine. It's going to be one of our tips. Anytime you are in the reciprocal identities, take them back to sine and cosine if you can. So I would say, if you know the secant, the reciprocal of secant is cosine. So this means our cosine has to be negative 2/5, so that when you do 1 over or flip the fraction, you get negative 5/2. Now, once we realize that our cosine is negative, this helps us out because if our cosine is negative, we have to be, let me do this in a different color, in quadrants 2 or 3. So that piece tells us, hey, together we've got to be in quadrant 2. So our specific angle has to be in quadrant 2. And then we already have one of our values. So I always find it's easiest to go for cosine or sine first. And then my next place is to use a Pythagorean theorem identity. Now, look back at your page. The one that is most familiar to you is that first one, hopefully. That's the one I think about first. So even though you could use the alternate versions, try to use, in this case, sine squared plus cosine squared equals 1. Because what you have is the cosine value. So you can now drop that cosine value and square it and go after the sine. Keep in mind, you're going to have to use your quadrant to know that the sine is positive in this case because you're in quadrant 2. And then after you know sine and cosine, you can do tangent. Then you can do cotangent, secant, and cosecant. Okay, so most of these involve some graphical reasoning and then a Pythagorean theorem identity. We're not really having to utilize those cofunctions identities in this one. And let's see, we're also not having to really do much with the quotients necessarily, except that we're finding, well, we're kind of using the quotient when we do sine over cosine. So questions here. So I wanted to remind you of this type because we've seen it before. And as we continue down, we have a few of those. Number 8 is like that as well. And then let's take a look at one like number 9. Okay, so this one is asking you to match secant x, cosine x with its simplified form. So it's a matching, and here are our choices. I'm going to put them and label them with letters here. But the first one is secant. Then we've got sine x, tangent x, secant squared, cosecant, -1, and +1. So when I'm looking at this one, I would like you guys to be able to cover up all of those choices and be able to simplify the expression. Sometimes if you think about doing that rather than matching, it's going to make life easier. However, if we just don't have any idea of where to start and it's a multiple choice like this, here's one strategy that works. Think about this as being able to graph that expression. Y equals secant x times cosine x. That's going to give you a graph in Desmos. Then if you graph each of these guys, secant x, sine x, tangent x, you're going to have a graph. The one that matches is the one that it simplifies to. So that's a quick check. But let's go back to what if we didn't have any choices at all. So out to the side, start with that secant x, cosine x. Should get my parentheses in the right place. So the first thing I noticed about this one is that I want to convert my secant back to either sine or cosine. So use that reciprocal identity. Say, hey, this guy is really 1 over cosine, and then I still have cosine. So this one quickly cleans up because we can think about canceling those, writing this guy as over 1, and then the whole thing simplifies to 1. Okay, so this guy. Now, again, our graph should have revealed that to us, but this one we could do pretty quickly without choices. Questions here? All right, so let's go ahead and look at some of the other ones. Number 10 and 11, 12, 13, 14 are very similar. They're match the trig expression with its simplified forms. Now, some of them are a little bit more complicated, so let's actually pick another one to do just to illustrate our thinking in this. And then we'll move on to our next type. So if we take a look at number 13 tells us to match this expression, secant squared x minus 1 over sine squared x. All right, so for this one, when I see I have my squareds, that tells me that I'm going to be able to potentially use Pythagorean identities. And notice with my secant squared, I have a reciprocal identity. So those are kind of my two things to keep in the back of my head. Pythagorean identities and reciprocal identities. And keep in mind there's a Pythagorean version of my reciprocal. So what I want to do is go back and focus on any of my identities that involve secant squared x. Okay, so going back to that box, keep this printed out, keep it handy. Do a little erasing here. I'm going to be over typing because the one we want, get rid of all this stuff, is, well, potentially this guy. Maybe we'll get rid of the rest of this stuff. It's not muddling it up. But that one is the one that jumps out at me first, right? 1 plus tangent squared equals secant squared. Okay, so let's go ahead and go back and write that down, compare it to our problem to see how it helps us out. All right, so when I look at this one, notice I don't just have secant squared, I have secant squared minus 1. And what I want to do is ideally replace the entire top part with something else. Here, if you take a look at this part, you can think about manipulating that 1 and subtracting from both sides. If I subtract 1 from both sides, I just have tangent squared x on the left, and secant squared x. Secant squared is, I think, one of the hardest ones to write. I'm always leaving a letter out. Squeeze that in, minus 1 on the right. So in this case, what we want to do is replace that entire red part with tangent squared. So when I do that, I get tangent squared x over sine squared x. Now, at this point, we still have squares, so I could potentially still use Pythagorean identities, but what I notice is I have a tangent that's not broken down into sine and cosine, and then I have another sign that could potentially cancel. So rather than trying to go after my Pythagorean identities, I'm going to try to go for a cancellation. So sometimes it's helpful to think about going ahead and writing this. Instead of tangent squared divided by sine, I'm going to write it as 1 over sine squared. That's going to allow me to separate those out and write that tangent squared as a quotient and simplify it easier. So think about if you wanted to rewrite, I'm going to go across here, tangent squared. Tangent is sine over cosine. So when you have tangent squared, sine squared over cosine squared. So don't let that confuse you too much going between just the singles and the squareds. But now we have 1 over sine squared. So at this point, I can go ahead and cancel those sine squareds. And it looks like I've got 1 over cosine squared. So let's write that over here. And now I'm going to keep on going, right? Because that's not one of my choices when we're looking at those choices. And furthermore, if I have a 1 over, I can go ahead and use my reciprocal identity. So if I had 1 over cosine, it would be secant. So this guy is secant squared. Now, if we look back at our options here, let's see. Oh, I didn't write the options for us, right? But the options on this one, secant squared was one of them. On my version, it's actually the last one. They gave us secant 1, cosecant -1, sine and tangent as the other options. So that one should work, right? But let's go through how we would check this guy in Desmos. Before we go over Desmos, questions here. All right, so let's go check this guy. I'm going to stop my share. And then, sorry guys, this takes a minute or two. I'm going to pop over and share my Desmos. All right, so you guys should be seeing the Desmos screen. So what we want to do in this case is think about graphing the first initial left side. I'm going to go ahead and put my division because I've got secant squared x. And we want to be careful here. Sometimes if you have secant squared, Desmos doesn't always understand those squareds for the reciprocal. In fact, I'm not sure. I don't remember if it does or not. Let me show you what I'm saying. So Desmos understands cosine. Okay, now Desmos also understands cosine squared. Notice that instead of -1 to 1, we're now 0 to 1. No negatives. But if I type cosine cubed, Desmos doesn't understand it. So I think we talked about this just a little bit in another class, but it only knows -1 and squared, like the reciprocal and the squared. So I don't know. We'll find out together. Here's secant. Don't know if Desmos knows secant squared. It looks like it does, right? But for example, if you try to type secant cubed, it doesn't know it. So sometimes if you're not sure if Desmos understands it for like the higher powers, you could type secant of x squared, squared, or in this case, I think it's going to work if we just do secant squared x like this. Okay, secant squared x -1. Sorry guys, trying to get those exponents to go. Yes. All right, so you've got our graph in blue, the original part. Now, as we were going through, compare what you have written down as your notes line by line. When we were working through the Desmos Exploration 5.1 before, we practiced the idea of checking line by graphing each and every step. Now, as you're getting good at these and you're practicing, do that. I'm going to do just my first step check, and then we'll kind of skip to the last one. So if you look back at your work, the very first thing we did was simplify to tangent squared x over sine squared. Okay, so that's telling me I have the right thing. Then we could keep on going for each step, or if I want to check my final answer, I got secant squared x. So notice if I want to take out those intermediate steps or leave them in, doesn't matter, but my blue matches with my purple, so I know I simplified that correctly. Or if you have two things that are always equal everywhere on the graph, it's considered an identity. You're always true whatever your value of x is. rather than being conditionally true at only particular values of x, like if our graph intersects, but they're not always matching up. So questions here. All right, let's go back and look and see if there's any other ones that I want to tackle before our break. And then we'll take a look at our Desmos a little bit more. So in terms of looking at that homework, you had a few that were the multiple choice, and then you have a whole bunch that were just simplify. And sometimes they say simplify, there can be multiple answers. I think we need to practice just a few more of those. But let's do this. What I would like us to do is kind of pop back over to our strategies with trig identities on Desmos. And I just want to remind you what we were doing before, right? Because you probably haven't looked at this in several weeks. So we had this one. I think everyone's already in there. So you can pull up your saved version, and a lot of you have made a whole lot of progress on it. So what I want to focus on, sorry guys, is kind of what people didn't get to. So a lot of you stopped kind of at the card sort. So that's where I want to take a look and just make sure we understand what to do here and how what we've been doing on paper can help us out. So I think that sometimes when we see a card sort like this in Desmos, it's just a lot of information. I have a whole lot of cards. It's easier if I start one place and then just start simplifying. So that is a strategy for you. If you understand, I see something that I think I can clean up, do it and see if you have a card that matches. For example, the first one that jumps out to me, or some of the ones that jump out to me, are like this one, right? So for example, if I look at this guy, sine squared minus cosine squared over sine x times cosine x, I notice that I have squares on the top. So maybe I can identify a Pythagorean identity. But all of my Pythagorean identities, like if I compare, I have sine squared plus cosine squared equals 1. So I'm not going to be able to just replace that squared part with a 1 or replace with a different squared identity. But I can't just cancel the sine squared and the sine and the cosine squared and the cosine. I have a subtraction on top, but a multiplication on the bottom. So that doesn't work. In this case, there's nothing that really jumps out at me to do, right? But if I compare that to potentially like this card, right? This card, it looks like it took two fractions and combined into one. So even though maybe I don't see an obvious place to go next, and maybe there is one, maybe there's not, I can kind of see, all right, here's a fraction. I actually have a common denominator, even though they're in reversed order. Cosine times sine is the same as sine times cosine. And those two actually pair together. And I need to be careful here because I wanted them to pair in the other direction. What it's wanting me to do is pair them in order. It's being tricky. And so that you can kind of read it down as a simplification of what your work would look like, or as a recording of what your simplification would look like. So I think we need to come back to this one a little bit more because I see other stuff with sine and cosine. But again, this one right here, I might not know where to go next based on what we've done. So here's what I would like us to do. I want to take a few minutes, make sure you guys get a break, and then we're going to restart the session. I want you to see if you can look at this sine squared x minus cosine squared x. Look at your Pythagorean identity. Even though you can't replace that top part with 1, can you use the identity to make a replacement and then find the next card that goes? So what I'm going to do is, let's see, it's 10:37 on my clock. Let's come back at about 10:45. That'll give you a short break to run to the restroom, grab a snack, try that problem, and then we'll resume. We'll do this and then we'll pop back to WebAssign. All right, guys, so I'm going to close this out. I'll give you guys a few minutes for questions when we come back, and then we'll pick up. Oh, before I end the meeting, just click on the link again, the Zoom link again, and I'll let you back in.